There are many different studies trying to estimate the impact of tick-borne diseases and impact of ticks. And of course, it's very difficult to divide it. So always when we speak about economic impact of ticks, we mention this or we consider this together with the tick-borne diseases. There are some data from one study showing like the importance of different tick-borne diseases in cattle in East Africa. I guess it was Tanzania, and you see that the most common and economically most important disease perceived from tick-borne diseases is definitely theileriosis. And what's important is that the same study showed that tick-borne diseases account for, basically we can say, great majority of calf mortality among the indigenous breeds and so on. And then we also can see that the impact, of course, depends on the way you keep the animals, which means on the production system. The impact can be quite different in agropastoral and pastoral systems. And of course, also in commercial dairy cattle, which are commonly kept almost indoor. And as you see here, the impact is much lower in number of mortality in the studied region than among the much lower in the dairy cattle than in pastoral and agropastoral settings, which is not surprising because simply ticks cannot find a way indoor. And this is also quite this polarization we clearly see also in European countries, of course. Yeah, while or when within the intense dairy cattle farming, we almost do not see tick-borne diseases, and tick-borne diseases are not really perceived as a problem. Once we go to beef cattle, which is almost year-round on the pastures, of course, the ticks themselves are an issue even in Europe, including Italy, of course, and the tick-borne diseases as well, as we will discuss later today. Yeah, so these are the data from same study trying to estimate the costs or the losses, the economic losses in millions of USD dollars. And you see that, and it was one country only, that the economic impact truly is huge. And what's important, and we will discuss that also later, that of course, the impact of tick-borne diseases doesn't depend or doesn't depend only on pastoral system or production system you are using, but also on the breeds. You probably know that usually the local indigenous breeds are considered more resistant to tick-borne diseases. And again, doesn't matter if we speak about Italy or if we speak about Africa or Asia. But the problem is that, of course, the productivity of these indigenous breeds is much lower. So there is always kind of trade-off the pastoralists are facing, either to keep the local breeds in higher numbers and have relatively small production that projects into smaller income, or whether to switch to, I would say, Western breeds of cattle with high productivity, both in beef and dairy cattle, but increase the risk of clinical impact of tick-borne diseases.
David, sorry. Are you sharing other slides, or are you always still in the first one?
No, I'm changing. So it's not changing
because you are you're stuck in the first.
Oh, okay. I'll try. So I stop sharing and try again.
Maybe go in presentation.
Yeah. Okay. I'll do it. Second.
We were watching your screen, but it was stuck in
I understand. I understand. So I will immediately solve it. Just a second. I'll open again. I just should find it. So this was this one. And I'm almost there. So it was here. Zoom. This one.
Okay.
And now you see the table, economic impact of ticks.
Yes, but
Okay.
please go forward or reward.
Does it work?
Yeah, yes, it's working.
Super.
Okay.
So first I was speaking about this slide. Sorry for that. I will just review very briefly, showing the differences between agropastoral, pastoral, and commercial dairy. In the mortality, if you look always to the first line, you see that the mortality that was Tanzania is highest in both in immature individuals and adults, highest in the agropastoral systems, while in pastoral system is a bit lower and very minimum in commercial dairy cattle. Why in true pastoral system it's lower? It's exactly what I mentioned in the last sentences before, that typical traditional pastoralists, they usually keep purely indigenous breeds, which are having much higher resistance to tick-borne diseases, and which results in much lower mortalities. If you look in all the diseases mentioned here, mortality of adults among the pastoral cattle is always lower than among those kept in agropastoral systems. The same is here, it's just translated to millions of dollars, so it shows, and it's just one study from a single country. So it shows that the economic impact of the tick-borne diseases or ticks is quite high. If you look what are the issues or what are the levels at which the ticks and tick-borne diseases cause the economic losses, we can divide them into several ones, of course, logically. First of all is direct mortality caused by ticks and tick-borne diseases, which finally, it's not easy to assess. It's not easy to assess even in Europe, but it's very difficult to assess in, for example, in Africa and Asia, because we need first the reporting system, and second we also need the definition what it means that the animal dies because of tick-borne diseases, because there is always a bunch of associated troubles. Commonly it's associated with the absence of the food during the dry periods. It's associated with some other ongoing diseases, malnutrition, and so on. So it's not even easy to say this animal died because of tick-borne disease or because of high tick infestation. Yeah. Which is the second point which I mentioned here. Yeah. So the interactions are quite complex, and we definitely know that in the areas of occurrence of those major tick-borne diseases in cattle and even the small ruminants, the tick-borne diseases are among the most prominent reasons for the direct mortality, indirect mortality, and also associated losses. Yeah. What's even more pronounced, or what we should stress even more, is that there is other type of indirect loss, and this is the decrease in production. And this is, of course, non-lethal clinical effect of the disease caused by general stress of the organism which is infected, lower motility or mobility of infected animals during the feeding, resulting subclinical conditions, and so on. Yeah. From different studies, people tried also to estimate what's the reduction in weight gain caused by a single tick that grows on the animal. This is true for Rhipicephalus mainly. And you see that it looks small, but it's not small. And if you look to Amblyomma variegatum, which is one of the truly pathogenic ticks in Americas, you see that they calculated that per a single tick, the animal is losing 60 grams of weight gain, which looks nothing. But if you imagine that there is 100 of these ticks in individual, then the losses are already quite significant. It goes in kilos and kilos of weight gain, which finally, of course, results in lower profit of the agropastoral system. And this is why we keep the cattle. We don't keep, of course, the cows for fun. We keep them, or farmers, they keep them for a profit. And if they are with us every single tick, they are losing the profit, then it's an issue, obviously. Yeah. So what are these indirect losses? They relate to the reproduction rate, decreased fertility, increased calf mortality. So the turnover of the herd is disrupted. But the ticks, they have also impact on the leather industry. You know that the leather, or the skin of the animal, the leather, is one of the important outcomes from beef farming, and specifically the large ticks, which are having the robust mouth part. We discussed them last week. It's amblyoma and hyaloma. They have really so powerful rostrum that they can really make the destruction to the skin and associated granulomas. They basically make the skin much less valuable, sometimes even not not marketable. And the farmers, basically, they have the skins, they don't know what to do with them, and the profit is lost once again. And then we have quite a big range of other indirect costs. We should still keep in mind that in tropical countries in Asia and Africa, the animals, both the ruminating and non-ruminating herbivores, are used as a drought animals. And we also should keep in mind that some of these diseases are transmissible to humans, and so on and so on. So in other words, or just to make the long story short, tick-borne diseases of livestock, wherever the livestock is on pastures, represent until nowadays serious issues, regardless the broad spectrum of control strategies we have. And this we will discuss in the next slides. And of course, we should also keep in mind that there are, on side of farmers, there are huge costs associated with control, treatment, and the prophylaxis. It is the chemoprophylaxis. It's the treatment by acaricides to treat the ticks. It's the direct treatment of sick animals for the tick-borne diseases where they are occurring, antibiotics, antiprotozoic drugs. It's the biological control of the ticks. It's the vaccination in the areas where the vaccine is applied, and so on. On the other hand, we should keep in mind that those are the costs for the farmers or livestock farming system. But on the other hand, this is the source of profit for pharma companies. And this is one of the drivers of the research. Yeah, so there is quite a lot of happening, and there is quite a lot of investments into the, both on the grant side and also on the company side or pharma industry side, into the control of ticks and also into the control of tick-borne diseases. So it's quite a dynamic field in veterinary parasitology, and it's good to know something about it. So that was the economic costs and the importance of the disease. So let's look into on the control and the treatment. We already understand the biology of the ticks. We already understand a bit of their distribution. So let's discuss how we can control them. It's not that difficult, but still it's quite complex strategy. So we can say that the only way how to really reach the economically meaningful control over the ticks in populations of grazing herbivores, domestic grazing herbivores, or the livestock, are really the strategic programs. It's quite complex, and the simple view that we have the cattle or we have cows and we just spray them and we solve the issue, it's far from being true, and it's far from being profitable. But there are still some good success stories showing that these diseases can be solved, at least at the local scale. For example, one of the most successful long-term projects was almost the eradication of cattle tick Rhipicephalus annulatus, that was dominant tick on cattle in the USA already in half of previous century. On the other hand, if we compare with the similar program that started already in 1920 in Australia to eradicate Rhipicephalus microplus, which is the most important, specifically in the tropics, the tick transmitting the diseases in tick-borne diseases in cattle, it was declared unsuccessful in 1980 in Australia. So basically the program failed, even though the government pumped billions of dollars into that for 60 years. Finally, it failed and created a lot of tension between the veterinary officers, between the farmers, and so on and so on. Yeah. On the other hand, again, if you look to the third point, quite short and successful campaign locally against the East Coast fever, which is theileriosis in localities in South Africa, was accomplished by principally breaking the life cycle of Rhipicephalus appendiculatus and almost eradicating these ticks from areas of intense grazing of the animals. And also Amblyomma variegatum, the pathogenic tropical tick in cattle, was successfully eradicated in some islands in the Caribbean. But those are only few success stories, to be honest. And it doesn't work again. Yep. And when evaluating the success or failure of the, or where we are, in other words, evaluate the usefulness of the tick control, we should always take into account the economic aspects, which is a kind of threshold for the treatment against ticks. So we always have to compare the efficacy of the costs and the profit which is saved. Yeah. And problem is that even the research itself, as is written in the first paragraph, which means the evaluation of intensity of the ticks in large herds of cattle, is quite demanding and expensive itself, which makes the true assessment of economic impact quite complicated. Yeah. And as a result, the benefits associated with tick control are quite different between the regions, but they are also quite differing between the studies. I just gave you a few examples in the following points. Yeah. So a study from Zambia in late 90s says that there is quite strong benefit cost 7-to-1 within a studied year, which clearly makes or shows that at least in given setting, controlling the ticks was truly profitable. The same in Zambia in the same study. But if we look to studies, for example, from Australia, they already say it's 1-to-1. So basically there is almost, not almost, there is no economic impact proven. Yeah. And there are some studies that are even showing the contradiction, like in Zimbabwe, where the study reported that the intensive treatment was responsible for the decrease of milk production and finally to economic losses. Yeah. So if we can conclude something, because this is really complex, and to really understand this, we really need an expert for this type of evaluation, and I'm not the one, definitely. But if we can say something in general, and it's mentioned in the last sentence on this slide. When we work with the tick-borne diseases and ticks in indigenous breeds of cattle, in areas with long-term occurrence of these diseases and so-called endemic stability, which can be even pastoral settings in southern Italy or Sardinia or wherever in Europe, it seems that the economic benefits of intensive tick controls are very small or almost negligible. Yeah. On the other hand, of course, if we go to the non-indigenous breeds, which are definitely more sensitive and also more expensive, and more sensitive to diseases and also more expensive, then the treating of these animals or permanent control of ticks on these animals, it's almost a must of successful production, specifically in beef cattle. Yeah, so this again a huge trade-off or dilemma whether to go rather for indigenous breeds and decrease the loss, the costs of the tick control, or whether to switch to high productivity breeds, but keeping in mind that then we should invest quite high money into the control of ticks and tick-borne diseases, which is true not only for ticks, but also for a range of other parasites, of course. Yeah. So what we should consider when designing the tick control program? What are the principles that are to be followed, investigated, and evaluated in such studies? Because this is essential, and it's essential even for the field veterinarians to understand that. Because for us, as for veterinarians, we tend sometimes to overvalue the administration of the drugs, because this is something what we can do, this is something what we can recommend, this is something what we can Google on our phones and recommend to the farmer, use this product in this concentration for this period of time and so on. But we are not that much familiar with the tick biology which is behind. And as I said, then we tend to overvalue or to put too much value on the treatment itself without understanding the possible limits, which finally means that in given situation, and it's not rare, the so-called help from side of veterinarian is not helping at all, because the farmer is investing money into the tick control, and if it is not done the good way, it means that he's losing this money. Yeah, and instead of getting profit due to veterinary assistance or advice, he is losing even more. Yeah. And there are many factors which I tried already kind of involved in the previous part of the talk on the tick biology that we should understand. We should understand the natural limits of the tick populations, and we have to understand the different biology of different ticks. There are huge differences between Rhipicephalus and Hyaloma. And they also transmit different types of theileriosis, for example. And we should really understand in given situation, in given farm, in given setting, what's the dominant tick? Is it one host tick, or is it three host tick, and so on and so on? We always have to really adjust the timing and the seasonality of the treatment to the tick life cycle. But again, this is not universal, because even in one country, it's not universal, and you can easily imagine that. The tick life cycle in the slopes of Alps in northern Italy, it's totally different from the ticks somewhere in Basilicata, and again, different from the life cycle of ticks in, for example, Sicily. Yeah, so all this we should, of course, consider when advising. Yeah, so we also should keep in mind whether we really want to control only the ticks on the animals, or whether we address also the control of questing ticks, which is essential, because treating only the animals where the questing ticks remain all around, it's usually without major effect. Other important thing we should, and we discussed that specifically in case of tick, Ixodes ricinus, the common European tick, we should understand how much the wild animals influence on the tick control program. And we should keep in mind, and this is not only for the large pastoral systems, but this is even for your gardens. Like in my garden here in the Czech Republic, we are living just in the middle of a hotspot of Ixodes ricinus in Europe. I have hundreds of ticks in our garden. I can control them by spraying, but it doesn't help, because every day the birds are bringing new ticks, because Ixodes ricinus is really spread by common birds which are all around, like the blackbirds or robins and other birds. And these are the animals that are bringing the ticks to my garden. And it continues regardless I'm treating or controlling the environment or not. So then economic feasibility of spraying my garden is almost zero, and the environmental impact is quite high, and this is something I truly don't want. So then we should find some other way how to protect ourselves and our animals from the ticks, but not trying to eliminate the ticks from the environment. Yeah. So let's look to the treatment and control of tick-borne diseases in different groups of animals. I don't go really into details on this. First of all those of you that are having the animal, you know quite a lot about this, because every owner of dog probably should care about prophylaxis against ticks and also tick-borne diseases. And there is nowadays quite a long list of products. And of course, there is also long, or not long, but there is a quite complex way how to administer. Yeah. What's important to keep in mind that there are basically two types of products, or two ways how they impact on the tick, or how they poison the tick, we can say. Yeah. Majority of products act by direct contact, which means the tick should get into contact with the drug, which is somewhere on the body of the host, and get poisoned and dies. Sooner or later, we will discuss that the speed of kill is quite important for different pathogens and their transmission. And then there are some drugs, and I'm sure you heard about them repeatedly because they are getting kind of popular nowadays, that are having a systemic effect, which means they are applied either orally or parenterally, and they circulate in the body, and the ticks and other ectoparasites are getting intoxicated while they are mainly via sucking the blood from such an animal. And typical group of, or typical examples of such acaricides are isoxazolines and selamectin. There are some subtle differences in efficacy for different tick species, but in general, we can more or less conclude that what's working for one tick species with high probability works also for other ticks. Of course, logically, the clinical trials are available only for few tick species, because technically it's not feasible to do clinical trial of, I don't know, whatever, selamectin or fluoralaner on 30 species of the ticks which are living in Europe or even more. Yeah, so we know the data usually for Dermacentor. We know the efficacy for Ixodes. Sometimes we know the efficacy for Epicephalus, and that's it. But with high probability, if the particular drug is efficiently protecting the animal from Ixodes ricinus, it's also with high probability protecting the animals from Ixodes hexagonus and other species of Ixodes and so on. Yeah. So if you look to the way how these products are applied, one of the most popular ways nowadays are spot-on application forms. They are usually used monthly, and commonly they include various combinations of antiparasitic drugs for acting against the parasitic arthropods. Yeah. I'm not going to recommend any of them here. I just want to stress, and it's really, really essential, that us as veterinarians, we should really keep in mind and keep understanding, or we should understand what's inside the drugs that we recommend to our clients and their animals. Not that much what's the name of the product, not that much what's our profit from selling the particular spot or particular collar or particular pills to the dog. But we should truly, truly care what's inside, because as you see, even from the list of those few drugs here, they are used in combinations. And there is always a good reason for the fact that they are in combinations. But commonly, there is also a good reason that they still remain on the market also as a pure substance, for example, like fipronil. And it's not the same whether you use fipronil, like Frontline is, or whether you use the drug which combines fipronil, metoprene, and cypermethrin. Yeah, and you should always ask yourself, okay, so why I'm recommending this, or why I'm recommending this, and try not to be biased by massive campaigns by pharma companies, because of course they want to sell, and that's fine. They want to sell particular products, which is also fine, but you are vets, so you should be above that. So you should really understand. And for example, one of the major things which need to be understood is the understanding which type of substances have also repellent effect, which is more important for diphtheria vectors of diseases than for the ticks. But even for ticks, it's important. And basically, there are not many, to be honest. And one of the most potent until nowadays is permethrin. And you should really look into the drugs that you are selling, whether you want to prevent the contact of the vector the way that you repel or use the product with the repellent effect, or whether you want to kill it, like in case of tick, and you are using an acaricide. So these are the spot-ons. I don't go to details how to apply spot-on. Yeah, that's basically something everyone knows. I want to mention one thing here. If you look to these products, and also if you look to colors, and if you look to orally applied antiparasitic drugs, usually they target both the fleas and ticks. There is no doubt. Most of the substances like fipronil or wherever else, selamectin, fluorouracil, and so on, they act both, and nicely they act against fleas and against ticks. And to be very, very honest, historically, those were mainly the fleas that were the driver of production of the new drugs. And if you look to the market, the old antiparasitic drugs for dogs and cats from the beginning of previous century, they were designed mainly to kill the fleas. Why? Because the fleas are going directly from dog and cat to the owners, and it's really not nice having fleas in your bed and having fleas in your house and so on. The ticks, they are always a little bit more elusive. They stay around somewhere in the meadows, somewhere in the forests, and so on. And this is quite essential difference. And it's always good to keep it in mind, because the owners of the animals, they keep asking what is the difference. Yeah. So if we speak about the dogs and about the control of the dogs, and we already mentioned that, we should keep in mind that absolute majority of ticks is in the environment and usually not within the households of the owner. Yeah, there can be some exceptions for Epicephalus sanguineus, but still, the dogs usually, or cats as well, they get infected when they are walking around. More you walk with your dog, or more free roaming your dog is, higher the risk of contacts with the ticks. But usually these ticks are not truly reproducing in your own garden. They are not creating populations at your balcony and so on. No, they are in the nature around us. And this is also why, regardless we treat our dogs or not, they will persist all around us in sufficient numbers, which is, as I already mentioned last week, good and bad news for the veterinarians. Yeah, because we can be almost sure that the tick control will remain an issue for coming decades, because we don't have other way. We simply have to protect every single dog with a collar, spot on, or pills. If you look to fleas, it's quite different. The fleas, and you know it because you know the life cycle of the flea probably, the fleas are holometabolic insects, where cycling from adult to larva to pupa and to adult back. And this is happening all around us. And this is happening inside our apartments. This is happening inside our gardens, inside our garages, and so on, everywhere where dogs and cats relax. the fleas are managing their life cycle. So, but they are not that much in the nature around us. The typical flea on dogs and cats is Ctenocephalides felis, and it's almost not shared between dogs and cats and the wildlife. So it means that when we really target the flea on our dog or cat, we can quite successfully eradicate, or so-called eradicate, the flea from our environment if we keep treating the animal for significant time, and if we keep in mind that the fleas are all around and that the larvae and pupae are all around. Yeah. And this is also a reason why, in general, in small animal practice, at least in the area of Europe, which I know, we see a really strong decrease in the prevalence and intensities of infections or infestation by fleas, but we don't see any changes in the tick population. So to be honest, I can imagine that we will be able to almost eradicate the Ctenocephalides fleas, at least in urban environment, but we cannot make significant impact on the tick population. And you have to explain this to the owner. You have to explain this, that this is not failure of you as veterinarian, that the dog is bringing the ticks again and again and again. You have to explain, no, this is the biology of the tick. This is the fact that all around you are the animals living, which are source of the ticks for your dog or cat again and again. And it brings you, of course, the continuous profit. Because if you explain well enough this to the owners, they simply keep buying the things. And if you keep selling, you keep your profit. This is it. Yeah. The normal veterinary practice is also selling the products and getting profit out of that. Yeah. So this is good news for you. So the ticks, and this is what I'm telling to all my students here and to vets, the ticks are not against us. The ticks are with us because they keep our business profitable. Yeah. So if we look to other ways, and I'll be faster now, if we look to other ways how to treat dogs and cats against the ticks, of course, we have the pills nowadays, basically based or mostly based on isoxazolines. Different companies are coming with different molecules of isoxazolines. This can be fluoralaner, afoxolaner, sarolaner, and lotilaner, and doesn't matter any type of laner. But their mode of action is basically the same. Most of them, they should be given monthly. Only fluoralaner is said that it can persist, the level of it can persist for 3 months. And this is why Bravecto is quite successful on the market. Question is how much this is true or not. It probably depends, largely depends on the lifestyle of the dog. But it's said that this stays longer. Then we, of course, we have collars. And one important thing to mention is that not all collars, the same is for pills as well, of course, and spot on, can be given both to dogs and cats. So this is another thing that you should really, really care about, whether the product is designed to be used in cats or dogs, or theoretically both. Yeah. And then there are also some other forms like shampoos, powders, sprays, and so on, but they usually have really low efficacy, and they are almost not used in the, I would say, professional control by the ticks, but they are still quite popular among the owners. And of course, there is also growing popularity of kind of alternative ways of tick control, both based on the herbal products and also some other means of control, but their true efficacy is questionable and truly depends on the level of the exposure. It can kind of work on the animals with low exposure to the tick population, but if the dogs are daily living in the habitat with high populations of the ticks, specifically in the areas of important tick-borne diseases, these alternative ways are not enough to protect the animals from the infections. So if you look to horses, ticks, of course, are important for horses. Later today, we speak about the Babesia and Theileria in horses. So most common way is the systemic application of the ivermectins. Other drugs are not used. Compared to other herbivores, you know that ivermectins in horses are normally given orally. But to be honest, they don't really protect the horse for a long period of time. So they can successfully remove the ticks and but cannot truly protect the horse. More efficient is then the topical application of the acaricides, which in case of horses can be used as puron, usually based on cypermethrin, deltametrin, permethrin, which are the pyrethroids, or sprays and powders, which are usually applied monthly, again, like pyrethroids and organophosphates. So in case of horses, the need for control of the ticks really depends on the season, the place, and the presence or absence of the tick-borne diseases. So it's not a universal must that all horses during the tick season should be protected against ticks. Definitely this is not true. But specifically the horses, the immunologically naive horses, which are coming to the areas with high level or high endemicity of tick-borne infection like pyroplasmosis, they should be carefully protected because they are in high risk of development of clinical pyroplasmosis. We'll speak about that later. I think that from my previous slides, it's obvious that the tick-borne diseases are of eminent importance, mainly for livestock on pastures, specifically for cattle. And this is why also the spectrum of acaricid treatment is the largest for ruminants. But Julia, can you switch your microphone off, please? Time to time we hear you. So if you look to the spectrum of the active substances which are used, it's not that broad. And again, I would love if you can keep in mind at least the basics. Yeah, that the purons are most commonly based on macrocyclic lactones or on combination of lactone with some other active substance, which is commonly not against the tick. So it's quite good if you use the combined products. It's quite essential to keep in mind which part of this combined product is against the ticks and which part is against, for example, the helminths. Yeah, if you look, for example, to ivermectin and combination ivermectin and closantel, then apparently, even though it's a mixture, the ivermectin is the drug that is against the ticks and other arthropods, and the closantel is against the helminths. The same is true for combination of moxidectin and triclabendazole. Yeah, we use it as a mixture, but again, the active substance, it's only the moxidectin that acts against the ticks. So these are purons, quite common and popular. Other than macrocyclic lactones are based on pyrethroids once again. So it's not really different from horses. Sometimes these are even identical products. And then, of course, and you know it quite well, we have also an injectable form. This is again mostly those are again mostly macrocyclic lactones, spectrum of them, moxidectin, doramectin, the same that were previously as purons, are commonly available also as injectables. Both the puron application and the injectable application depends on, of course, the level of contact with given animal. So in large herds, in large pastures of beef cattle, both can be quite tricky and demanding. You can imagine that if you have 1,000 of beef cattle somewhere in Arizona on pastures, it's not that easy to give a shot of ivermectin every month to each of them. That's basically, we can say it's impossible. And the same is true even on European pastures. We did quite a lot of work with helminths of beef cattle on pastures in Czech Republic. And basically the owners, they see these animals only twice. So you can apply the drug only twice a year before you put the animals to the pasture and at the end of season when you take them down from the pasture. So coming to them and saying, hey guys, you have to give them injection of a shot of ivermectin every month, they would consider you crazy because it's such a huge amount of work that no one is willing to do so, unless the animals are truly dying for tick-borne diseases, which is not that much happening in Europe, to be honest. Yeah, but there are some other ways how to protect the animals for a long period of time, and quite interesting way are medicated ear tags, which are shown here on the picture, which is basically kind of porous plastic soaked in some acaricide or insecticide drug and releasing this into the environment and on the body of the animal. And these are based either on pyrethroids or organophosphates or macrocyclic lactones. And this is one of the popular ways because they simply last longer. And anyway, in most of the areas, you have to mark the animals, of course, so you can combine these. And then spraying and dipping. It's usually quite wild procedure. The animals definitely do not like it, but you can imagine that this is, of course, effective. And again, you use more or less similar products. We don't use for these, of course, the ivermectins because they are simply too expensive for this, but we use pyrethroids or we use organophosphates to control the cattle. So to conclude somehow about the treatment against the ticks in any kind of animals, it's always quite complex. You as veterinarians and also the animal owners, they always have a huge or broad spectrum of the drugs that you can use. You have broad spectrum of the way how to administer them. But the duty of veterinarian is together with the owner to find a way which is easy, as cheap as possible, and working. Yeah, many of these approaches can have advantages. Many other can have also disadvantages, and it's always the knowledge of the local situation, the knowledge of the lifestyle, the knowledge of the on the tick biology that can really help you to design or to tailor, we can say, the tick control strategy either for individual animals, like in case of the dogs, or for individual farm settings around you. And this is the expertise of veterinarian. Your expertise is not to identify the ticks. For this, you can ask any parasitologist around, please, what type of ticks is this? But no one will help you to design the strategy or to interpret what it means that cattle on the pasture that you are supervising are having this type of ticks in this quantity and transmitting this type of pathogen. Okay, so simple things that you will be probably asked a billion times by the owners or also by your family when having the tick. What is the way to remove the tick? So, of course, people nowadays agree that the only good way of tick removal is just the mechanical removal of the tick. So don't use alcohol, don't use petrol, fire, or oils or whatever. Try to catch the tick as close as possible to its cranial part, to the skin of the host, and simply pull it out. So this is the right side picture. What's the difference between the right and left side picture? Even though it looks insignificant, there is a big difference, and it is that on the left picture, you are squeezing the body of the tick, which basically helps to transmit the pathogens which are inside. So, for example, if the tick is infected by Borrelia or Babesia, and if you really squeeze it hard, no surprise that basically you flush or push all the infective agents from the tick to the host skin. So this is not the way, and always try. And there are special devices for that nowadays on the market, of course, those simple kind of plastic stuff and so on. There are many ways how to do so. So always try to catch the tick as close as possible to its head. In dogs with long fur and so on, it's not always possible, but at least do it on yourself. When you are affected by ticks, keep it in mind, have the proper tools, and try to remind the tick the right way. It truly helps. Fine. And last but not least, we can ask ourselves, are there any alternatives to this? Until now, we spoke about the chemical compounds, and we spoke about the ticks living in the environment, and it doesn't really match. You know that if there is something we truly don't want, is to contaminate the environment with tons of toxins, which are toxic against the ticks, of course, like any of those we mentioned. But the same way, they are toxic to any other invertebrates which are occurring in the same environment. Yeah, which means killing the beetles, killing coprophagous beetles, which is a huge issue. I'm not going to that, but it's a huge issue. But killing also the butterflies and grasshoppers or whatever is on the pasture, including the aquatic crustaceans, for example. The ivermectins, as such, they are highly toxic for aquatic crustaceans. And if you treat your cattle on a pasture, within a couple of weeks, all the drug you give to the animals goes in feces to the pasture. With the first rain, part of that moves to the nearest water bodies, and then the aquatic organisms, the planktonic organisms, are truly affected by that. So we should ask, are there any alternatives to control the tick? We can say, yes, there are. Some of them are more promising. Some of them are still at the level of, I would say, experimental work. And I mention here only two directions. For those of you that are interested, you can briefly check these two articles. Both are open access articles that you can easily Google within a couple of seconds on your mobile. And the example on the left side is using the entomopathogenic fungi for the tick control. And there are ongoing experiments for maybe 4 decades with fungi that are killing the ticks. But only recently, some of these treatment or control strategies are really reaching at least I would say reaching the level of the real life. It's not in laboratories, it's not in petri dishes, so it's not in experimental animals somewhere in experimental stables. No, this is already happening. These clinical trials are already happening in the real situation with the real animals on the real farms, which is the case, or example of such studies is the one on the left, using the fungi to control the ticks on pastures. The paper, which is the review paper on the right side, reviews the vaccinations against the ticks, specifically Rhipicephalus microplus. Definitely, it's a future. There is no doubt. And there are so many trials to develop, or so many teams and so many different approaches to develop a vaccine against the ticks, that no surprise that there is some success. The problem is, and again, it takes us back to biology of the ticks that we discussed. One of the basic conditions of successful treatment by vaccination of host is that the tick should live as all stages or should be truly dependent on this host. And this is a big problem, for example, in Europe, because the dominant ticks on cattle we have here, they are not single host ticks. Yeah, there are 2 host, 3 host ticks. And always part of the tick population is, and we discussed that, it's in other hosts, it's in wildlife, it's in carnivores, it's in birds. And then vaccinating cattle against these ticks cannot truly help to eradicate or to break down their populations. But huge exception are the single host ticks on the pastoral systems. Imagine that you have a huge farm, fenced, you have 500 cattle there, and you have population of Rhipicephalus microplus. Yeah, this is the tick that lives only on herbivores. This is a single host tick, so all the development is occurring on your cattle. And then if you vaccinate the cattle with some efficient vaccine, then logically you hit the population of your ticks really seriously, and within a short period of time, you can eradicate that from the given area. And then, of course, if you transpose this approach to the broad mass scale campaign, it can truly happen that you eradicate the tick from given geographic range, easier on the islands, more difficult on the continental system, but that's doable. And definitely this is future for single host tick, like Rhipicephalus microplus. But don't be surprised and try to understand that there is no vaccine against hyaloma. And maybe there is some way towards vaccine against Ixodes ricinus, but it will never destroy the populations as such, because 99% are not living on the vaccinated animals, they are living on the wildlife and so on. Yeah, so keep this in mind, but I truly recommend going through both articles because it's interesting and it shows the future. So if you look if there are any solutions or any conclusion for this first part regarding ticks, and I want to say definitely there are many, and we already mentioned part of them, but I want to stress one thing that is important to keep in mind, that there is always, even though there is always an exchange of the ticks between the wildlife and the domestic animals, still what's really essential and what stays behind is traveling with non-protected animals is really extending or expanding the ranges of the ticks and mixing the ticks from different regions and bringing the tick-borne pathogens to the new regions. And if you want to have some very short or concise or robust source of information that it's easy to read before the exam or it's good to understand for your common praxis, I can direct you a little bit to the websites of ESCAP, which you probably know, or if you don't know, I truly suggest you to check the website of ESCAPs, because this is a online platform that is trying to summarize the information about the different parasitic infections, about the vectors, about the pathogens, into a form that is understandable both for veterinary practitioners, but also for the animal owners. And if you want to know the basics, go there, check it. It goes through so-called guidelines. And if you look to the example which I'm giving you here on the right side, there is a updated guideline called guideline number 5 on control of vector-borne diseases in dogs and cats. And if you go to that, it's from 2019, relatively recent. You find quite a lot of information that will be useful, not only for your exam, but also for you while dealing with ticks and tick-borne pathogens on your dogs and cats or on your horse as well. And so there is another guideline for horses, as far as I know. Fine. So, break. Are you there? 10 minutes is fine for you?
Yes, that's fine.
Thank you.
Super, fine. So 10 minutes, so we continue 10:15 with Babesia and Theileria. So thank you for your presence. I leave the presentation on and see you in 10 minutes. Have fun. Enjoy your coffee. So, hello everyone. Are you there?
Yes.
Super, super. Don't you sound really pessimistic. Yes. Be optimistic. It's Monday, whole week ahead. And fine, let's start. So, after having a couple of hours or spending a couple of hours on ticks, we now move to tick-borne diseases. Please don't be surprised that it will be partly, of course, again about the ticks. It's absolutely impossible to separate the ticks from tick-borne diseases unless we are truly clinicians. But to be honest, this is not topic for this talk. We are not clinicians. I'm not teaching you how to manage the anemia. But we are a little bit ahead. We will discuss if the anemia can be caused by tick-borne parasites, how we detect these situations, and what can be done with that. So because, of course, if you look to the tick-borne diseases from purely clinical perspective, and it's not surprising, of course, the dog or cat or horse is not coming to you or to us with a question, what type of Babesia do I have? No, that's definitely not. The dog is coming because it's sick. And usually in the very first moment, we even don't know what organ systems are affected and so on. And slowly, of course, logically, through the procedure of diagnostics, we soon or later reach the point when we start asking ourselves, okay, is it possible that this is a tick-borne disease? What is the diagnostic step I can do? First diagnostic steps are usually quite easy. We use some snap test, we use blood smears, or we submit the material for the PCR diagnostics, for example, to commercial labs. But then it's still the beginning. It's not the end. Because if we have the result, and we already mentioned that, if you remember well, in last week, if we have a result, it doesn't mean that the issue that we are seeing in our animal is caused by the blood parasites we are diagnosing. And this is one of the most difficult things, specifically in areas with a high level of endemicity of tick-borne diseases, that specifically when we use the sensitive tools, we see these pathogens in quite high number of the animals, also in situations that they are not causing any harm to them. And to diagnose this as, for example, babesiosis, can be quite misleading if the dog has some other issue. Yeah. So, and this is the rule for parasitologists. So I would say the first rule is for clinical veterinarian to identify that there is a situation that theoretically can be caused by tick-borne disease, Babesia theileria. Then there is a second level, which is the diagnostics, which I still don't consider parasitology. It's basically work for technicians. You do a blood smear, you switch on the microscope, you examine the microscope. Nowadays, you possibly know that artificial intelligence is already doing so. Yeah. You possibly heard about a system which is called Vetscanimagist by Zoetis, and it's examining the blood smears for parasites using the artificial intelligence. So you put the slide into machine and you get the result. So this is not the science, this is not parasitology. But what's parasitology is the proper identification of the parasite, not only saying this is Babesia, but saying, oh, this is a dog, okay, so this is dog from this region, and this is finally not Babesia, it's not Babesia canis, it's Babesia vulpes. And so this is the desired level of diagnostics. And then the real veterinary parasitology start, because we should understand what it means for the host, what it means for the epidemiology in the given region, and also we have to, together with the clinician, to design the treatment and save the life of the poor animal that is suffering on your table in the beginning. Yeah, so it's quite a long procedure. And I'm trying to give you some hints during my talk how to think about these things and to see the links always between the ticks, between the clinical status of the animal, between your diagnostic skills and opportunities, and between the management. So I have quite long introduction about the history of Babesia because I find it quite fascinating, but I promise I will go extremely fast through that. So don't be surprised that I'm skipping the slides. You can later anyway, I'll give you the presentation, so it's recorded. So you can go through that and check it if you are interested in this. So basic things. We speak about pyroplasmids. What are they? They are apicomplexan parasites. What are apicomplexan parasites? Tell me some other apicomplexan parasite, please. Tell me some apicomplexan protist other than pyroplasmids. It's a question.
Toxoplasma.
Exactly, toxoplasma, so-called coccidia in general. Yeah, heteroxenose, monoxenose coccidia is a kind of sister group to pyroplasmids. So we still remain within the epicomplexan. So basic things are the same. They have apical complex. They are living inside the cells. They are intracellular parasites. All pyroplasmids are tick-borne, or let's say vector-borne, and specifically pyroplasmids are tick-borne. So we can say that any pyroplasmid we are speaking about is transmitted by ticks. And what's important is extremely tightly associated with the given tick. Yeah, so it's typical heteroxenose life cycle of a parasite. And it's good to keep in mind that the vertebrates are only intermediate hosts, and the tick is the definitive host. Does anyone knows why the tick is definitive host? By definition? Why the tick is considered definitive host? And to make it short, yeah, tell me.
Because the protozoa can replicate.
Exactly, because the sexual, they can replicate in both, but the sexual reproduction is happening in the definitive host. They replicate also in the intermediate host, red blood cells and so on, but this is asexual. This is merogony or schizogony, whatever we call it. But the gametogony, the sexual reproduction, takes part in the tick. And this is also why these parasites are, basically we can say they are co-evolving with the ticks. We will speak about that later. So, and we should keep it in mind. So this is why their distribution doesn't depend on distribution of cattle. No, distribution of bovine, different bovine species of bovine pyroplasmids depends on distribution of particular ticks, because they are associated with them. In other words, I can only say that the ticks are just exchanging the pyroplasmids through cattle. They are sending them to mammals, letting them to reproduce asexually in mammalian hosts, and then sucking them back with the blood. Yeah? So the tick is the true beast in the life cycle. Yeah. Fine. Okay. So this is a very basic introduction. Other thing that is important to keep in mind that they were always here, the pyroplasmoses. It's nothing new, even though we consider them emerging in some regions. They were also always, of course, always here. And they are, as I already mentioned, they co-evolved with their hosts in particular systems. So, for example, where cattle was, or the ancestral bovines were living with some particular tick species, different species of Babesia evolved in area, co-evolving with different ticks. And also the tick-borne diseases were here always since the animals were domesticated, and there are already some, I would say, hints about the existence of epidemics of tick-borne diseases, for example, in the Bible, speaking about the fifth plague and so on and so on. Yeah. So definitely tick-borne infections are here. We already mentioned last week that they're among the first heteroxenose parasites discovered with the full life cycle, or when epidemiology was truly understood. And it has quite nice history. Two research lines happening quite a long time ago, as you see, 150 years ago, in simultaneously in Europe and in the more or less in Americas, where the epidemics of a disease manifested by so-called blood urination happened. The massive outbreaks happened in, for example, in southeast Romania, which is marked by red on the picture down there. And this is where the research of babesiosis started by, in the time, Romanian parasitologist Victor Babes. And this is from the Babesia name is coming, just it's to know why, to let you know why it's Babesia. Yeah, it is Babesia because it was basically discovered by a prominent East European parasitologist, Babes. Yeah. And then there is some taxonomic history. I like showing these pictures here because it shows, or for me, it's amazing how really accurate the observations of this, I would say, pioneering parasitologists were, and their pictures in the original description of Babesia bovis, or in the time Hematococcus bovis and so on, are better than those that we are able to draw nowadays. Yeah, so those were the real masters of microscopy. And what was interesting, similarly, in very similar period of time, the disease very similar to babesiosis in Europe was described in the United States, causing by other species of pyroplasmids in that time called Pyrosoma bigeminum, nowadays Babesia bigeminum. Yeah? So these are the two main species in cattle, Babesia bovis, Babesia bigemina, and so on. Yeah? So this is the deep history, and it takes a little bit more time to describe the theileriosis as a cause of East African coast fever. We speak about that very soon. Currently, the parasite is known as Theileria parva. And somewhere in the 50s, 60s, there were first cases of babesiosis detected in humans. Of course, it was happening even before, but it was basically unknown disease. Yeah. So if you look to the two main genera in the traditional taxonomic system, as this one mentioned in one of the Bibles of protozoology in Lee et al. In 2000, we speak about two major genera, Babesia in the family Babesidae, Theileria in the family Theileridae. So far, all good. But to be honest, when I show you the phylogenetic classification schemes that are based on the real reconstruction of the evolution based on molecular data, it's not like that. And the situation is much more complex, which is creating quite a lot of confusions, not only among taxonomists, but also among the veterinarians. And it's quite difficult to sometimes to understand this. And sometimes it's not sometimes. And commonly, it's quite essential. One nice example is a parasite of dogs in Europe, which was described originally under the name Theileria annae, something like 30 years ago. So if you look to the good and a bit older papers, you see theileriosis of dogs caused by Theileria annae. If you go to more recent literature, the same parasite is called Babesia vulpes, causing babesiosis of the dogs. Yeah. And if you don't know that this is the same, then it's becoming a bit confusing. And honestly, I'm discussing this pathogen with clinicians around, and they are truly confused. Because the companies are offering the diagnostics of Babesia vulpes, but they see the studies from Spain and Portugal on Theileria annae and so on. So you should keep in mind that the names are changing, but the pathogens are the same. And even though it looks unimportant for you as for veterinarians to know all these taxonomic, also boring taxonomy, unfortunately has a huge impact on the terminology that we are using. Yeah. So let's look a little bit inside the diversity. I promise that I will not speak about too many species, but still we need to understand how the diversity, at least in the major host of Babesia and Theileria, is. Let's start with Babesia. Yeah. So there is a group of species known in cattle. What's important is always the third column. Look that different species are transmitted by different vectors. And logically, if you look to the very right column, the distribution, logically also different species are distributed in different areas of the world. Yeah. So cattle, quite a big group of species. Later we speak about individual ones or the important ones. Also, sheep and goats are affected by a couple of species of Babesia in the old world. Babesia cabali in horses. The pathogen you definitely know. And then we have something in pigs, almost unknown pathogens of pigs. Interestingly, some years ago, kind of little epidemics of babesiosis was described also in Sardinia from pigs that are grazing in the oak forests. Then we have a group of Babesia in dogs. I will speak about them tomorrow. And then we have some others, of course. Yeah, so it's quite a diversity for a veterinarian to understand. And we cannot say these are important, these are unimportant. All of them can be important in particular situation, in particular areas. Yeah. If you look to the overview of Theileria, it's a little bit narrower, the spectrum. These are the well-known traditional species. Annulata parva are the major species in cattle. Ovis and separata in sheep and goats. Theileria ane is the one, this is quite old table, is the one that I mentioned before, which is nowadays Babesia vulpes, not Theileria ane. So just even here, these contradictory taxonomic things are obvious. And nice examples of another relatively recent change in taxonomy is that Babesia equi, the parasite of equines, common parasite of equines all around the world, including Italy, was transferred to genus Theileria. So what was before known as Babesia equi in older studies and by older generation of veterinarians, it's nowadays treated as Theileria equi. And you probably know it already as Theileria. And I'll also speak about it, or I will refer it to as Theileria. So this is another table that relates to Theileria. I'll skip it because we go to that later. And let's go to basics of the biology. We already discussed that Babesia in Theileria is nothing more, nothing less than heteroxenous apicomplexan. And because it's heteroxenous, not surprisingly, that its life cycle is divided into two hosts. It's two-host life cycle. So part is happening in the vertebrate. This is the asexual part. And part is happening in the tick, which is the sexual part. Yeah, where the gametes are formed, fused, and zygote is happening, it's appearing, and so on. Yeah, so these are the two things which are present both in Theileria and Babesia. But then in the life cycle, the Babesia and Theileria, or at least those those we know the life cycle, because their life cycle is really in detail, it's studied only for a few species. So those few species of Babesia studied, they are typical by two, I would say two major things. So try to keep two things in your mind. First of all the life cycle in the vertebrate host, this is the red part, is happening in the red blood cells. So it's simply a parasite of the red blood cells. Keep it in mind and you'll be fine for the rest of your career. This is one thing. And the second thing, in many species, or at least in those we know, there is a transovarial transmission in the tick, so which is in the blue part. Yeah. So the gamogony is happening in the tick. We are somewhere here. Yeah. Gametes are produced, they fuse, they create zygote. Then they create so-called kinets or ookinets, produce the sporozoids, which is the typical stage in the life cycle, invasive stage of life cycle in the apicomplexans. And they are then in the ticks, in the tick eggs. So this is transovarial transmission. Sorry, the transovarial transmission is here. Yeah, so through the kinets. Yeah. So in the female organism, the motile parasite is infecting individual eggs. And logically then, the ticks which are hatched, the larval ticks which are hatched from the eggs, contain the sporozoites, which affect the vertebrate. Yeah? So repeated reproduction in red blood cells and transovarial transmission. These are the basics for most of the species of Babesia. If you look to Theileria, the basic division is the same, of course. Vertebrate host, tick. Vertebrate host, asexual reproduction, tick, sexual reproduction. But what's important here, that the lymphocytes are involved. Yeah. So in most of the Theileria, the life cycle is divided into two parts. During the initial phase of the development, they parasitize in various types of white blood cells, typically in lymphocytes. And at the end of the endogenous part of the life cycle in vertebrates, they are in the infected red blood cells. Then we see them as typical parasites in red blood cells, very similar to Babesia. Yeah, but there is strong part, or the major part of development is in white blood cells. And this is also the part responsible for the pathogenicity. And this is important to keep in mind. So, for example, the anemia and hemoglobinuria, it's not really a typical part of the lives of the clinical symptoms in most of the Theileria. This is not happening that much, yeah, because other types of cells are infected. And when we move to the tick, the life cycle in the tick is very similar to previous one. The only exception is there is not transovarial transmission, which is quite important because logically only the larvae and the nymphs can be infected to finally, as adult, transfer the infection to another vertebrate. So not all ticks fits into this biology, and not all the three host ticks. For example, if the larvae and nymphs are present in other hosts than the adults, then it's commonly the life cycle cannot happen. So, for example, Ixodes ricinus truly cannot transmit Theileria in cattle, because the larvae are not and nymphs also not normally not sucking the blood on cattle and so on. Yeah? So the ecology of different tick species kind of prevent the transmission of some of the species because there is not transovarial transmission. Yeah. So repeated merogony in the lymphocytes, no cyclic development in red blood cells, which means no massive destruction of red blood cells, leads to different pathogenesis, and there is no transovarial transmission. So these are the key facts for those few species of Theileria. Their life cycle is well studied. So at least very basic things of epidemiology. In general, and I already mentioned that a little bit before, the indigenous breeds are always more resistant than the, I would say, fancy high productivity breeds. And specifically the crossbreeds with zebu cattle are more resistant to pyroplasmosis. What's important, and this is something that please try to remember, that the adults and immunologically naive animals are more susceptible. Why this is so important? Because it explains why the animals which are grown on pastures, that are born and grown on pastures in endemic areas, they are commonly only subclinically affected, because they manage to develop an immunity during the either transplacental transmission of the antibodies or during the first weeks of their life. They develop some level of immunity, and then they are well protected from the clinical outcome of the disease. The worst scenario that can happen for animal is to be an adult, immunologically naive, being transported from non-endemic to endemic area. And this is exactly what's happening all around us. It's happening with cattle breeds across Europe. It's happening with horses. The horses, they travel so much. And for example, in the Czech Republic, we almost do not have Babesia interior in horses, which means majority of our animals are immunologically naive. And then imagine that you are living here and you sell your horse, or you send your horse for some race somewhere to Mediterranean, where pyroplasmids are occurring normally without clinical science in horses. So then this horse, with high probability, if it is confronted with the ticks, will acquire the tick, will get sick, and can easily die due to acute pyroplasmosis. And this is the basics. This is true for the dogs. This is true for cattle. This is true for sheep, whatever. So please try to keep this in mind. This is a biologically and epidemiological baseline. The animals that are living in the endemic areas are less susceptible to the disease than animals that are coming to endemic areas. I will go to that again and again. And another true things which should be considered are those two remaining lines, that individual species of pyroplasmids are associated with particular ticks, which defines the geography and host range. So the host range is not defined by the species of pyroplasmid. We cannot really say this is typical only for the dogs, because there are many exceptions. But we can say this is transmitted by this particle tick, which is happening, and this can happen there and there. I'll give you examples from the same map that I already showed you. This is the map of European distribution of common ticks on dogs mainly. And we see two dominant species. In the orange circle is Dermacentor reticulatus. And if you look where on the map are the orange spots, it's not clearly visible, but we discussed that last week, so it's just repetition. It's across the Central Europe. And this tick is a vector of Babesia canis in dogs, which is more pathogenic than the second species of Babesia in Europe, Babesia vogeli, which is transmitted by other tick. And this is the one in the green circle, and it's Rhipicephalus sanguineus sensulato, and this is what's marked in the map by the green spots. So you clearly see that central part is definitely more orange, and southern part of Europe, including Sardinia, is definitely green, considering the color of the spots. So then logically, there is quite strong difference in babesiosis among the dogs which are living in northern Italy or Switzerland or Germany or Czech Republic, and those that are living in southern part of Italy, because you guys down there, you have predominantly Babesia vogeli, which is for sure less pathogenic than us in Central Europe, which are having Babesia canis, which is responsible for acute babesiosis in dogs all around. And similar principle we can observe in many other pyroplasmids. And I will go to that again and again and again, but maybe I'm too repetitive. But from my point of view, for the veterinarian, this is essential to consider. Yeah, so because there are differences between the ticks, and there are differences between the tick-borne diseases. It's not the same if you diagnose Babesia canis and Babesia vogeli. It's not the same, even clinically. Yeah, so you should keep it in mind. And there are even bigger differences between some other species. And then if we add here Babesia vulpes as a third species, that's totally different. And what's important, even the treatment is totally different. Totally. Yeah. So if we have a dog which you see so-called Babesia in the blood smear, and you immediately consider that Babesia canis, which means you start to treat it with midocarb, you probably fail and the animal can die because simply it's not working. Yeah. And before you realize that it's different species of Babesia, the dog can be already dead. So it's really quite important to understand these differences. So, and also there is quite a big change in paradigmatic view on host specificity of pyroplasmids. We tend to kind of derive the host specificity from the name of the parasites. Like Babesia bovis, oh, this should be in cattle. Babesia canis, oh, it should be in dogs and so on. Yes, it should, but there are exceptions. And when the tick is crossing from one host to the another, it can also transmit the disease to another host. And the other host can be really clinically ill. Yeah, there are cases of canine pyroplasmids in horses. Yeah, there are cases of Babesia bovis in horses. The same way, there are cases of Theileria annulata demonstrated in dogs and so on. Yeah, Babesia cabali and Theileria equi were transmitted, were proven to be transmitted in the real situation to dogs. So we can say, yes, there is host specificity, for sure. But in the areas of co-occurrence, it can be easily broken or crossed by the pyroplasmids. And with high probability, if we don't use the molecular tools, we can also misdiagnose the pyroplasmids, of course. Because if you have a dog and you see Babesia in its blood smear, you say, oh, it's a dog, so logically it's Babesia canis. Oh, no, it's not canis because I'm living in southern Italy, so this should be Babesia vogeli. This can be Babesia vogeli, and with high probability it is Babesia vogeli. But in the same time, it can also be Babesia cabali, because you have also the infected horses around. And from the smear, you cannot say that. From the basic PCR, you also cannot say that. Yeah, so you really need to go to a little bit more advanced things to understand what are the true species that are circulating in the given settings in particular regions. And the same is true for all groups of pyroplasmids. And unfortunately, this is also true for zoonotic cases. Yeah. Quite interesting group of closely related pyroplasmids that were discovered just recently is a group of Babesia in European game animals, specifically in deer and roe deer. It's it's very narrow group of pyroplasmids that belongs to so-called group 6. And it includes Babesia divergens, Babesia caprioli, Babesia venatorum. All of them present all around Europe, all of them present also in Italy, probably not all present in Sardinia and southern Italy, but still, these are the parasites around. They are morphologically identical. They have the same vector, which is important. They are transmitted by Ixodes ricinus, but they have quite differences in pathogenicity among the different types of wild herbivores. And what's more important, only 2 of them, Babesia divergens and Babesia venatorum, are transmissible to humans. And we can ask why particularly Babesia caprioli was not found yet in humans, we have to say. We can ask why they are relatively easily, I'll go to that later. No, why they are relatively easily transmitted to humans? Because they are vectored by Ixodes ricinus, which is the most common tick on humans in Europe. So the level or the rate of confrontation between the human population and these pyroplasmids, it's quite high, because ricinus is the most abundant tick that sucks the blood on humans. Other interesting thing is the story of Babesia divergens itself that was discovered just recently, and we kind of contributed to that with my team here in Czech Republic. Because if you go to the literature, Babesia divergens is typically considered a parasite of cattle. It was described from UK, to be honest, from cattle herds. It's considered to be an endemic in some regions of Europe in cattle herds and so on. But what was discovered just recently, thanks to the molecular tools, that in fact the most infected hosts in Europe by Babesia divergens are not bovines, but they are the red deers. And obviously, it's normally a parasite of the red deer. And you know that populations of red deer in Europe are growing instantly, growing all around Europe. And the Babesia divergens seem to be present in all of them together with some other pyroplasmids. So it's not the only Babesia in deer, but it's the Babesia in deer which is transmissible to cattle. And it can either spill over and spill over to cattle and remain in the herds of cattle as endemic, which is the situation in Ireland or UK, or it can only occasionally be transmitted between the deer and and cattle, and this is probably the situation in other European, or the dominant situation in other European countries. And interestingly enough, for example, in the Czech Republic, we have Babesia divergens very common in deer, like 30% of the animals, I would guess. And we almost do not see infection in cattle, because simply they are probably isolated enough by fenced pastures, by different habitats. So they simply, their ticks do not cross, don't overlap, and the transmission is not happening. And Babesia divergens is zoonosis. Yeah, so we have in Europe in general quite abundant source of zoonotic Babesia, which are the red deer, living almost everywhere in forested areas, having high prevalence of potentially zoonotic pyroplasm that can be transmitted by Ixodes ricinus, a tick which is dominant on humans, to human individuals. Yeah, so this is basically reviewed here, so I already told you the story. It's not Babesia divergens, it's not the only zoonotic Babesia. The most common infection in humans is so-called Babesia microti-like microorganism, or Babesia microti sometimes called, which is in USA, transmitted between rodents and humans by ticks. And also in Europe, it's also the species which is called either Babesia venatorum or sometimes Babesia EU1, which is quite prevalent in all around Europe in roe deer, but also in the deer. That was in previous picture visible, and also causing cases in humans. What's important to mention that specifically in Europe, the human infections by Babesia, either venatorum or divergens, are happening only, or almost exclusively, I can say, in people with severe problems of the immunity. So in heavily immunocompromised people, typical are the splenectomized people. Yeah. And in them, the infection can easily be lethal. And these are typically the people which we really cannot recommend going out to the forest, spending the time in the area where the ticks are occurring, because the prevalence of these parasites in ticks is quite high. And the risk of infection and successful transmission by ticks, it's too high. So this is the particular group of people that should be really very strict in protecting themselves from the tick bite, specifically in the areas where the deer and roe deer are occurring, which people do not know, to be honest. And even the physicians, they don't know. They don't really give these recommendations to their patient. Don't go to the forest, be aware of the ticks, protect yourself strongly by the repellents if you go out, and so on. Yeah, so this is still, we still have a lot of things to do in Europe in awareness. So let's move to bovine theileriosis. We divide, we speak today only about the pyroplasmids in herbivores, and we divide it into bovine theileriosis, bovine babesiosis, and pyroplasmosis of horses. Yeah, so basically 3 topics that I still hope to manage to discuss today in the next half an hour. So let's start with bovine theileriosis. It's a devastating disease, one of the major issues for cattle breeding all around the world, and it's probably the most detrimental tick-borne disease among all. What's important to know, and it's, again, I really wish you to remember, this is not one disease. There is nothing like bovine theileriosis. Bovine theileriosis is a group of diseases. There are at least 3 major species of theileria transmitted by different ticks and causing different disease, requiring different management and understanding of the local context. Let's go through them. The one which is called tropical theileriosis, it's a big paradox, is the one which is occurring in Europe as well. So don't be misled by the name. It's called tropical, but it's the European one also. The distribution of theileriosis in Europe, you see more or less in the map. The countries in which it does occur are marked in yellow. And what's important to know is that it's transmitted by hyalomatics, those large ticks of the herbivores. And what's important also to know that it's present in Italy. And even though the map of Sardinia on the map is not marked, I am not sure if it is not just the absence of the data or maybe even the kind of ignorance by the author of the map, because otherwise whole Italy is marked. So definitely you do have hyaloma in your island, and with high probability you also at least might have Theileria annulata in your cattle. If we look to the frequency of its occurrence in Europe, we can depend on serological or PCR studies, and in the areas of occurrence of the vector, the hyalomatics, which is more or less the Mediterranean in Europe, it's quite prevalent. If you look to the first yellow map, you see that reverse line blot detected the parasite in 17% of animals, of bovines. From Madrid region of Spain, 22%. Italy, Sicilia by IFAT immunofluorescence method, 26%. Greece, 2% in some region of Macedonia. The percentage itself is not important, but the presence is important. Here in the table 1, you just see the results of the serological survey in Sicily, which is the one mentioned in the previous table as well. And you see that the prevalence in individual herds was, first of all, differing, and second, was not really high. Was not really low. Yeah, in some of the herds it was up to 70, 60%, 50%. Yeah, so it means, but this is the serology. So it means that the animals are well in contact with the pathogen in Italy. It doesn't mean they are sick. This is important to consider. This is only the epidemiological study showing how many animals were confronted. And in all these farms marked by asterisk, it was also proven that those were tested by PCR, and infection was proven also by PCR, which means it was active infection. The parasite was there. So it shows it's present. It's present in southern Italy, for sure. We have then the second Theileria, which is Theileria orientalis, causing so-called oriental theileriosis. Yeah. Typically, it's the Asian species. To be honest, I think that the areas which are marked in red here in Europe are the areas of imported disease, because we don't have the vector. The typical vector of Theileria orientalis is Hemaphysalis longicornis, known as Asian longhorn tick, sometimes called also shrub tick or bush tick or whatever. And what's important, this is one of the most invasive tick species. So even though originally it lived in Asia, it was accidentally, together with cattle, transmitted to the United States, where it was discovered just recently, and it's establishing the populations along the East Coast. It's known in South America, and it's causing big troubles to beef cattle farms also in Australia and New Zealand, where it was also introduced, of course. Yeah. In US, it's quite new. In Australia and New Zealand, it's known for a relatively long period of time. So this is oriental theileriosis. And then we have so-called East Coast fever, which is the truly detrimental theileriosis in African cattle. It's transmitted by, again, totally different ticks. It's transmitted by Rhipicephalus appendiculatus and zambesiensis in South Africa, and some other species like Rhipicephalus dutoni in more in these regions. It also occurs in Angola, even though it's not marked here, it occurs also in Angola and so on. And why it is called East Coast fever? Because it more or less occurs alongside the East African coast where these ticks are being present. This is a bit more detailed map of its distribution from one of the studies. The black color shows the distribution of the disease as such. The blue color shows the distribution of the tick where the disease is not detected but still occurring. And of course, these are the areas of easy introduction from the black areas to the blue ones because we have the vector in there. Yeah, but as mentioned before, it can be transmitted also by some other epicephalus ticks. If you look to some general facts, it's a bit long slide, but I wanted to put a bit more information here because it's not that straightforward. If we look to the pathogenicity of theileria, we can conclude that the common things are the same. It's as a disease, it's acute lymphoproliferative disease. Yeah, it can have high level of morbidity and mortality in susceptible populations. What is susceptible and what is not, we already discussed before. Yeah, the indigenous breeds living in the endemic areas are not much susceptible. In them, it's causing the high morbidity or prevalence, but very low mortality and vice versa. If you look to the differences, these are just literature data between those three types of the disease. East Coast fever, it's really highly pathogenic, and it can really truly cause 100% mortality if the animals are imported from non-endemic to the endemic areas. However, in the endemic areas, among the endemic ones, the morbidity can be up to 100%, which means every single individual is infected, but the productivity losses are, I would say, moderate or decent. With tropical theileriosis, again, it seems to be more severe in European breeds. The mortality rate locally can go quite high, but on the other hand, in indigenous breeds or in cattle living permanently in endemic areas, it can be very low, even though the morbidity is quite high. And the oriental theileriosis depends, of course, on the frequency of contacts with the ticks. And it's a bit different in fact that the pregnant individuals and the calves are highly susceptible. And again, in endemic areas, the mortality can be quite low. If you look to the diagnostics, you are veterinarian. So if you look to the diagnostics of theileriosis in cattle, it's achieved by the combination of endemicity in the given area, of course, clinical examination, and laboratory testing. Yeah. Doing only one without the others, it's losing the point. So you truly have to take it as a complex issue. So the incubation period is relatively short. And field diagnostics is achieved, like the confirmation in the field is achieved by proving or finding the theileria parasites in Giemsa-stained blood smears or biopsies from the lymph nodes. We do the fine needle biopsy usually and the smear. But in areas of co-occurrence of several species together, which is mainly Asia, we cannot truly distinguish between the species based on the morphology. Then, of course, we go more to the serological and PCR-based detection systems. If you look in detail to East Coast fever, which is probably having the most pronounced clinical features and the highest mortality, it's typical. Is the disease typical with anorexia and the acute disease, pyrexia, enlargement of the lymph nodes. It's a real lymphoproliferative disease. Please don't expect anemia. Don't expect hemoglobinuria and so on. This is simply not happening. This is a huge difference from babesiosis. Theileriosis it's not a disease of red blood cells. It is present in the final part of the life cycle. It's present in red blood cells, but it's not a disease of these cells. Yeah. And it's also obvious from the postmortem findings. You find quite unspecific findings like pulmonary edema, interlobular emphysema, enlarged hyperemic lymph nodes, ulceration of gastrointestinal systems. Yeah, so to make a proper diagnosis based on just very general finding, you first need to know that you are living in the anemic area. Then the local vets, they know. They can tell you per distance this is theileriosis because all their life they are doing nothing else than treating causes of theileriosis. But for untrained specialists, even like pathologists, this can be quite difficult if you are not familiar with that. So then you need a PCR, you need the imprints of the organs, you need the biopsies, you need to see it, you need to find it. Yeah. Oh, this is what I already said. This is the diagnostics. What's interesting is the control of theileria and theileriosis. And I will go to that honestly once again, but I'll go to that later. I have another slide for that. Sorry for this. Oh, no, I have it here. Sorry. So, because disease is so widespread, and because I speak about Theileria parva, the East Coast fever, and because it's causing such a big damage to keeping the cattle on pastures, and because it's truly immunogenic, it was really proven that it really elicits the strong immunity response. Already since 1960s, there are attempts to propagate the parasite in tissue cultures and develop the vaccines. And development of the vaccine passed through the 3 stages, which are quite similar also for other pathogens, but here it is very pronounced. Yeah, already in the 60s, 70s, there were the studies dealing with parasitized cell lines and trying to inject these cell lines to the animals, producing the immunity. And it worked. It worked relatively well. And Israel, as it's mentioned there, based their national vaccination program for annulata in this. But it's quite demanding because, it's not easy to work with the cell lines. It requires quite demanding facilities for the cryopreservation of the aliquots, transportation in the liquid nitrogen, and so on. So basically, this way was more or less abandoned. For Theileria parva, there was another direction used, and it was experimental infection of the animals and simultaneous treatment with oxytetracycline. And this is something which is happening until nowadays. It's quite, for us in Europe, where we have all those high-tech vaccines for the dogs and so on, and where we are trying to limit usage of the antibiotics, it sounds as a kind of hardcore immunoprophylaxis, and it is hardcore immunoprophylaxis, but it works well, and it's really saving lives of herds and herds of cattle all across Africa. It's based on a mixture of 3 isolates. It's broadly known in the literature, a so-called Muguga cocktail, which even this sounds a bit brutal. And it's used to immunize cattle, and because it's a mixture of 3 strains, it's giving quite broad protection against field isolates of Theileria parva. Of course, it has constraints, and this is why it is not that broadly used across Africa, and they are more or less logistic. First of all, it's done by the sporozoites. How you produce the sporozoites? You produce the sporozoites by ticks or on ticks, which means if you have to keep 3 strains on ticks and infect three strains of the parasites on cattle and infect the ticks, it's a lot of logistics. So it's not truly a biotechnology. You need a herds of cattle that are infected. You need the thousands of ticks which are feeding on them. Then you smash the ticks. You produce the sporozoites. You have to titrate those, not to kill the animals, but to infect them. And the infection shouldn't break through the tetracycline treatment. Yeah. And again, you require the liquid nitrogen to distribute the vaccine. So this is used way. It was big breakthrough in the prevention of East Coast fever across Africa, but still, logically, this is the way that soon or later should be replaced by more fancy or modern ways of vaccine. If you look to small ruminants, so those were the three main tail area in large or in cattle. If you look to small ruminants, also in them, there are the species. There is not that much known on their epidemiology. For sure, then can be pathogenic. There are some studies, or most of the studies are from the Far East, from China. There are some studies from the Near and Middle East where Tailera lestogardi is transmitted in goats by hyaloma. And specifically in the Asian areas with high production or big herds of sheep, like some areas of China, these are the diseases of concern. In Europe, we can say that the normal vets are hardly confronted with tick-borne infection, this type of tick-borne infection in sheep or goats. So that was bovine theileriosis and a little bit on small ruminants. Let's move to babesiosis. It's the second group of pyroplasmosis, again in bovines. Again, a range of species. At least 3 of them are quite broadly distributed. And again, differing quite a lot in their tick vector. And then again, differing quite a lot logically in their distribution. Yeah. By the way, in the previous section as well as here, you see a link to fact sheets of Iowa State University where quite nice PDFs really nicely summarizing bovine babesiosis and bovine theileriosis. So when you are preparing for exam or when you are interested in knowing more on this, I truly recommend this link, which is down there, as well as the one on the previous slides. So what are the vectors? Babesia bovis and Babesia bigemina, the more distributed and more pathogenic species of bovine Babesia, are transmitted by Rhipicephalus, specifically by those single host Rhipicephalus ticks like Rhipicephalus microplus, or also by Rhipicephalus appendiculatus and so on. So they are chiefly distributed in the areas where Rhipicephalus ticks in cattle are dominating. The other species like Babesia, the less important species, Babesia major, Babesia ovata, are transmitted by Hemaphysalis, largely in Asia. Babesia occultans by Hyaloma, again, mainly Asia. I'll show you the map soon. And this is just a repetition. We already know that Babesia divergens in Europe is transmitted by Ixodes ricinus between deer and cattle. So huge differences. So again, finding Babesia in a cow doesn't truly say which species of Babesia is that, but the region can help. If I find Babesia in the Czech Republic, where we have largely only Ixodes ricinus, I would expect Babesia divergens to be there. I will probably sequence that, but still I would expect divergence. If we are working somewhere in Africa or Asia, then bovis bigemina are definitely more probable. Eastern Europe, a bit of mixture. Even Southern Europe can be a mixture of these species. Yeah, so we already discussed this. Yeah, so the red areas of Europe These are the areas of Ricinus. Logically, these are the areas of Babesia divergence. Yeah. Clinical aspects of bovine babesiosis. We already said before that babesioses, in contrast to theileriosis, are infections of the red blood cells. They have cyclic development and mass destruction of the erythrocytes. And this is a pillar for their pathogenicity and also diagnostics. Yeah. So the major features of the disease is simply a consequence of destruction of erythrocytes, which is hemolysis and resulting anemia. And diagnostically, it's not definitely surprising for you. If there is intravascular hemolysis happening, then logically we see hemoglobinuria or hemoglobinemia and then hemoglobinuria. And this is the most prominent clinical feature obvious to the owner. So we can combine with the non-specific features. Yeah, so it's typical febrile disease. As a result of fever and also anemia, there are changes in the heart and respiratory rate. There can be icterus, but there is hemoglobinuria, the dark, almost black or chocolate-colored urine, as you see it in this syringe. This is typical sign that usually the owner is seeing or observing. And doesn't matter whether it's a cattle or dog, to be honest. Yeah. So this is what they usually report, the black urination or dark urination. However, the whole pathogenesis or pathogenesis is more complex. And for example, in Babesia bovis, quite essential part of all the process of development of the disease are immunologically mediated adhesions of the infected red blood cells in the capillaries of the brain, causing the neurological symptoms. So the disease doesn't necessarily to behave as a typical disease of blood cells, but the first sign the owner can report to the veterinarian can be the neurological symptoms, which, for example, in large parts of South America can resemble rabies or can mislead you to different type of the disease. So normally we don't associate Babesia with the CNS disorders, but it can be. And what's important, and we are saying that again and again, animals that survive the acute phase, and there are many, to be honest, they develop lifelong chronic infection and become a reservoir for the next generations of the ticks. Yeah. So the incubation period is moderately long, between 2-3 weeks after the exposure to the tick. And the pathogenicity is very variable, dependent on the overall health status of the animal, dependence on its non-specific innate immunity mechanisms, but also dependent on previous contacts with the same pathogen. It should be the same species and protective levels of the immunity. So just to show that locally, the situation can be quite complex, not locally, but in particular areas. This is a map from quite nice recent study of the distribution of different species of Babesia in China, with involvement of different tick species, with involvement of different stages, and with involvement of different types of the animals. Yeah, so China is big, of course. It's not a country, it's almost a continent. So no surprise the diversity is there, quite high. And what's more important that in some regions, you can see several species co-occurring, at least in given region. But in the same time, you see that the distribution kind of copy the distribution of the tick vectors. Yeah, like for example, Babesia orientalis, which is transmitted by Hemaphysalis. It's occurring mainly in eastern part of China where the tick is common. And in other areas, it's replaced by the species transmitted by Rhipicephalus and so on. So it's again the same story. I hope that at least something remains in your memory. If you look to treatment of bovine babesiosis, it's not that complicated. The first thing you have to think about is definitely imidocarp. And in different areas of the world, there are tens of different products containing the same. So based on the place where you are and based on the local registration, usually you have access to one or two. So there is not much selection. If you go through the internet, you find the products like of billion of names, all of them containing imidocarp, all of them are as intramuscular injections. But if you go local, you realize that maybe there is just one in your country. In most of the Europe, it's imizole. In areas where it is registered, still the diminazine is used, usually known as Berenil, but as far as I know, in Europe, in general, this is not registered in many countries. And what's interesting, in some of the countries, there is no registration for such drugs. For example, in the Czech Republic, we don't have even imizole registered. So if the Czech veterinarians wants to treat these relatively uncommon diseases, they have to import by themselves, or they have to ask the company to bring it, which can take time. So it's also one of the things that we are at least considering here, that I'm always telling the vets, specifically because of canine babesiosis, make sure you know where you can get imizole around. And there are usually a few clinics in the region that are storing the imizole permanently. And then if you have a sick animal, it's definitely time to ask these colleagues to give you imizole instead of importing that across the border, because the animal can die in meantime, of course. Yeah. So if we look to control of bovine babesiosis, it's not that differing from control to theileriosis, and we'll still speak about that. And it's combination of it's based on alive attenuated vaccines. It's using or promoting the genetically resistant breeds, commonly with zebu crossbreeds, and it's the tick control. Nothing more, nothing less. But it's not only the treatment. If you want to save an individual, of course, it's about the treatment. If you want the farmer to help with the situation, you need the tick control first, or combine with the vaccination. In the previous slides, we discussed the vaccinations against the pathogen itself, but of course, in the areas where the single host ticks are occurring, and we already mentioned that a bit, we can also control the Rhipicephalus by the vaccination. And this is the only way how to contribute significantly to eradication in given region. Fine, last minutes, last slides. Equine pyroplasmosis. A topic which is commonly discussed in Europe by equine veterinarians because it's broadly distributed disease. Oh no, it's broadly distributed pathogen, but relatively rare disease with quite complicated management. So, and it's not the diagnostics what's problematic, as I will show you. It's the interpretation of the data and understanding, because I would say we don't understand well how this is happening. So, again, under the name equine pyroplasmosis, we understand the diseases, two diseases with quite overlapping clinical features caused by two different parasites. It's Theileria equi and Babesia cabali. Again, I recommend quite nice fact sheet by Iowa State University, but now we can go to comparison. Of course, they are transmitted by ticks. So what they have in common and how do they differ? Theileria equi has only transstadial transmission in ticks, while Babesia cabali has transstadial and transovarial transmission. Which is not that important for the host. And you can consider it's not that important for me. I'm veterinary and treating the host. Okay, so we can go further. And there is things which is connected with the previous one, and it's the presence in the equine bodies or organism. So Theileria equi is usually said to cause lifelong infections in horses, while Babesia cabali is causing self-limiting, relatively short-term infections. And this is already making the difference. And Theileria equi is possibly also transplacentally transmitted. But why the second point makes it so different? Because we are back to what we already discussed, and it's PCR diagnostics. Nowadays, if you want to diagnose Theileria equi or Babesia cabali, you simply send the material to some company for PCR or real-time PCR, and they will do it for you overnight. But the interpretation can vary, because in case of Theileria equi in endemic regions, we normally see tens of percent, easily 15 to 25% of the horses being positive. But I mean clinically healthy horses. Yeah, so it doesn't show much. While in Babesia cabali, the presence of the DNA can a little bit more be linked to possible disease. Both pathogens are quite similar also in the blood smears. Theileria equi, even though it's Theileria, occurs in relatively good numbers in the blood smears that can help the diagnostics. By the way, guys, my computer says that my battery is running off. So if I disappear, this is the end of the lecture. I will try to finish. I have like one more slide, but if computer shuts down, have a nice day. I continue. So the most important thing is, and it's important for you because it's true also for your region, that the asymptomatic infections with both are common in endemic regions. And what's even more confusing is, or complicating, that commonly they do occur together. So we have many samples all across the area that we studied, where Babesia cabali is found together in Theileria equi in asymptomatic animal. So interpretation of such finding, it's truly quite complex. And they say that even the treatment specifically against Theileria equi is very problematic. I mean, the treatment is not that problematic. You use imidocarb again, but cleaning the parasite from the host body is almost impossible. And then, and this is maybe a final note that you can recommend, the treatment is normally not recommended in asymptomatic animals with low level of parasitemia, because with high probability you fail anyway, and you just give an extra chemical things to the horse, which is clinically healthy. And this is what I already mentioned, and it's the last note. We should be very careful when we are transporting the naive animals to the endemic regions, which is typical in sport horses. And the horse can be immunologically naive because of two reasons. First reason is that it's really coming from the area where the disease is not occurring, or simply it is kept in the way that it doesn't have contact with the ticks, which is not that surprising because a lot of expensive sport horses are kept almost indoor. And when they go out, they can be protected against the ticks in given. So they don't have a chance to develop the immunity. But then they go for a race, or they are sold somewhere to the Near East or to Southern Europe, the horse for $1 million. And it can die within a couple of weeks because of babesiosis, because it has no immunity. And these animals should be really particularly strongly protected against the ticks. Diagnostics, it's quite straightforward. Laboratory combined with the DNA detection. Here I just want to mention that both the species, Theileria equi and Babesia cabali, can be found also in dromedary camels, in the areas where horses are living together with camels, but they are not causing the disease in camels. So far, there is no clinical report of a clinical disease in dromedaries. But in the Near East, it's quite present, quite prevalent. And last but not least, a little bit excursion to conservation medicine. Pyroplasmosis is one of the leading issues, logically, in the reintroduction of wild horses from European zoological gardens to Central Asia. Why? Because exactly what's happening is what I mentioned. The horses are raised in the environment. The endangered and expensive animals are raised in the environment where the ticks are absent and the pathogen is absent. Then they are taken to planes, transported to Mongolia, and released in nature reserves where the wild horses are present and where the infected ticks are present. And logically, these immunologically naive animals are then acquiring the pyroplasmosis, and then it's one of the factors that contributes to their mortality and one of the factors that threatens the reintroduction projects. So it just to show that pyroplasmosis and tick-borne disease are not only issues in the domestic animals, but in particular situations, they can represent a problem also for the wildlife, specifically in case of reintroduction projects. And that's it. So thank you very much for your patience. If you are still there, have a nice lunch. Bon appetit. And see you tomorrow. Tomorrow we'll speak about the carnivores mainly.
Thank you. See you tomorrow.
Welcome. Have a nice day.
Thank you very much. See you.